Hello Chem class, it's Mr. Ng, and I have a short little video to remind you how to write ionic formulas. Let's get into it. So I have three problems here: potassium oxide, and we want to know how to do the formula for these things. A few rules before I get started. Number one, you always start with the metal, right? Start with the cation, right? The metal, and you want to end with the anion, the nonmetal. And when you end with the anion, the nonmetal, you always end it with "ide", I-D-E. Unless it's going to be a polyatomic ion, but I will talk about that in the next slide. Then lastly, make sure that they cancel. Make the charges cancel. All this makes a lot more sense once I do a example or two. So here I have potassium oxide. The first one is potassium, which is right here, potassium. And if you recall from our lessons on the periodic table, we know all of these guys will make a 1 plus ion. Why? Because they're alkali metals. They have one extra electron. They're going to throw that one electron away. We're going to have a +1 charge. These guys will all be +2. These guys will all be +3. On the same note, all your halogens will be -1. All your oxides, the oxygen group will be -2. And then the nitrogen group will be -3. Seems easy enough. So potassium we know is going to be K plus. Oxide is going to be O2 minus. So we know it's going to be KO something or another. And if you notice, there's 2 minus and a 1 plus. They're not going to cancel out. So it takes 2 Ks to cancel out that 1 O. So I'm just going to write K2O, and that is my formula. Another thing that you could do is you could just do that kind of crisscross rule, right? So the 2 goes here, the 1 goes there, K2O. Let's try another one. Sodium bromide. Sodium is right here, so we know it's Na plus. Bromine is right here, so we know it's Br minus. 1 plus, 1 minus. They cancel 1 to 1, so the formula is NaBr. Last one, iron 2 bromide. Iron is in here. It's a transition metal, so we don't really know exactly what charge it has. So iron actually has multiple oxidation states, meaning it makes many ions. There's like iron 1, 1 plus, iron 2 plus, iron 3 plus. But you'll normally only see 2 and 3. So here, iron 2 bromide, this is going to be Fe2 plus. The formula tells you the oxidation state already. We already know that bromide is Br minus. Let's do the little crisscross applesauce, right? It takes 2 bromides to cancel out this one iron. So now we have FeBr2. Why? Because it takes 2 bromines to cancel out the 2 plus of that one iron. Hope that's making sense for you. If not, please rewatch this part. Let's go on and talk about polyatomic ions. Sometimes you don't have one element. You have many elements making up your ion. For instance, ammonium. Ammonium is right here, and the actual formula is NH4 plus. So many atoms come together to make one ion, but the rules are still the same. So NH4 plus, so it's 1 plus. A chloride, if you look on the periodic table, is Cl minus. A +1, a -1, they cancel 1 to 1, so we could just write NH4Cl. That is our formula. Copper 2 sulfate. Copper 2 is Cu, Cu2 plus. And then a sulfate, let's look for it. A sulfate is SO4 2 minus, SO4 2 minus, 2 minus, 2 plus. They cancel out 1 to 1, so it's CuSO4. Seems pretty easy, right? Last one, ammonium carbonate. So ammonium is again right there, NH4 plus. A carbonate is right here, CO3 2 minus. This does not cancel 1 to 1, so let's do that little crisscross rule, right? So this becomes NH4. Look at the notation. there's going to be 2 ammonia, so we're going to put a little parentheses and put the 2 outside of the parentheses. 2 ammonia, and then there's only going to be 1 of these carbonates, so we could just write CO3, right? Seems really easy. Make sure that these things cancel out. Easiest way to cancel them out is to do that little crisscross rule, or just think about it like how many chlorides does it take to cancel out a copper 2. Hope that's been helpful, and I will see you guys in class. Thank you for watching.